Ladies and gentlemen, my name is Gawel Solosky from Bengal University in Turkey. I'm going to present you documentation from sugar and protein. Documentation is a special case of anaerobic digestion that stops in the process of producing acids, and during this acid production is hydrogen generated. If it would be unstopped by means of pretreatment, or even in some cases naturally stops, so the process will continue as methane production. The bacteria which are producing this process are coming from the sludge. Usually it's coming from the cow gut or chicken manure or sludge where is bacteria, and we seek mostly on Clostridium type because these bacteria are most most efficient. There are some also and mesophilic mostly, so living in the temperature between 36 and 40 degrees Celsius optimally. The fermentation can also occur in bacteria that are thermophilic. For example, some bacteria that live in the Vesuvius lake which are extremophilic, are also producing hydrogen, especially are checked on feeding the winery waste. And these thermophilic are also producing some lactic acid more than, while mesophilic mostly besides organic acid like butyric or acetic acid is also producing hexanoic acid. The feed of these bacteria are considered to be carbohydrate waste, which are digested optimally in pH 5 to 6, where enzymes which are iron chelates or vanadium chelates works most efficiently. If pH will be lower than 4, lower than 37.7, this enzyme will stop and bacteria will close in the sporate form. The bacteria production of hydrogen occurs in the phase of changing from sporage form into clean form of bacteria. So we need to keep this bacteria in this interface layer to keep stable, and this is the old trouble. The feed of the bottle feed is glucose. This glucose change into butyric acid and hydrogen, which is most common due to high probability due to the lowest Gibbs energy. Lower Gibbs energy seems that reaction will be more spontaneous and thus more probable. It also can produce some propionic pathway and acetic pathway, which can produce even 4 molecules of hydrogen. Besides this which is glucose, we need to feed of carbohydrates like starch or cellulose transfer into solution of saccharose, glucose, fructose, or other short organic matter. The best is think to be glucose. Concentration needs to be usually thought to be 20 and 30 grams of sugar per liter because of reactants, because for 1 liter of inoculum. Because otherwise, the bacteria sporage form disappears too fast and stop producing hydrogen and starts producing methane. We don't want this methane production because overtakes this hydrogen, because methane process use this hydrogen to more efficiently. And this is also one of applying method of dark fermentation bacteria that we help to improve the production of methane in anaerobic digestion in so-called bioethane production in such case. We check that proteins also can produce. And these proteins also produce butyric acid and hexanoic acid, so-called also caproic acid. And this production of hydrogen sulfide emission is also because there are 2 pathways, in fact. One pathway is producing this from glucose, this hydrogen by in the interstage where is pyruvic acid. Parallelly, there also occurs production of hydrogen sulfide from this bacteria sporage and rest. And protein given by to the feed prove that it's from the rest because knowing the volume of hydrogen sulfide that would occur if only from feed is much this pathway. So for also producing hydrogen sulfide from this bacterial waste and sporage form. Thank you very much.